right. Focus. Oh, holy. Okay. All right, 10-4 is called using inscribed angles and polygons. So we're sticking with the circles. The circles aren't going anywhere. They're going to hang around for at least the end of the chapter. Okay, we're going to add to different kinds of angles and then how to find the measures of those angles in the arcs. So an inscribed angle is defined as an angle whose vertex is on the circle and whose sides contain chords of the circle. So what's the difference between this and a central angle? Where's the vertex of a central angle? In the middle, on the center. Okay? So central angle, vertex is on the center. Inscribed is on the actual circle itself. And then it says that the sides contain chords, because technically these are chords, right? But the sides of an angle are lines, which means this whole thing is still a continuation of the side of the angle. So technically, those would be secants that contain chords, okay? The part inside the circle would be the chord, and then if it extends outside, it's the secant. Theorem 10.7 says the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So where a central angle is equal to the arc, the inscribed is half. It's further away from the arc, so it should make sense that it's smaller, right? If I drew a central angle that had the same point on the edge of the angle, that is closer to the arc, making those sides of the angle spread further apart. So if I pull it back, it should make sense, hopefully, that it's smaller than the central angle. It's exactly half the arc. So if this arc is 80 degrees, what's the measure of angle ABC? 40, okay, half. And then you can do vice versa. So if this was 60 degrees, what's the measure of the arc? 120, good. So angle is half the arc is twice the angle. Theorem 10.8 says if two inscribed angles of a circle intercept the same arc, then the angles are congruent. All right, so if you looked at this, right, like, so if I look at angle 1, that's here, this is angle 1. Angle 1 intercepts what arc? Arc AB. So if I had the value of arc AB, how would I find angle 1? It'd be half of it. Good. So now look at angle 2. Angle 2 intercepts what arc? AB. So let's say that this arc was 100 degrees. What would be angle 1? 50. What would be angle 2? Makes sense that they're the same, right? So if two angles intercept the same arc, then they're going to be congruent, because they would both be half of the same measure.
So 20 would be 60?
Exactly. All right, so inscribed polygon and circumscribed circles. So an inscribed polygon is a polygon with all of its vertices on the circle. Think about the word inscribed. It sounds like inside. The triangle here is inscribed in a circle. You could have a quadrilateral inscribed in a circle. You could have a hexagon inscribed in a circle. It just means that all the vertices would be on the circle itself. And then circumscribed means it's on the outside. So circumscribed circle is the circle that contains the vertices of the inscribed polygon. So what's on the outside, you would say, is circumscribed, and it's the word about. So I would say that that circle is circumscribed about the triangle, or circumscribed about the quadrilateral. So the inside one is inscribed, the outside one is circumscribed. Okay, Theorem 10.9 says if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. And the converse to that, if one side of an inscribed triangle is the diameter of the circle, then the triangle is a right triangle, and the angle opposite the diameter is a right angle. All right, so if you look at the diagram on the bottom, it says the measure of angle ABC is 90 degrees if and only if AC is the diameter of the circle, which means that ABC is 90 degrees if it's the diameter, and the reverse. If AC is the diameter, then the angle that would connect to the endpoints of that diameter would also be 90 degrees. And again, hopefully this makes sense. Think about what's happening. If this is my angle, it's intercepting this arc, right? Classify that arc. What kind of arc is it? Semicircle. What's true about a semicircle? 180 degrees. So that if this is an inscribed angle, it is half of 180 degrees, which is 90 degrees. Okay? And vice versa. If I gave you the 90 degrees, then I would know that I would do it times 2 to get the arc. The arc will be 180, which is the semicircle, and then you would know that segment is the diameter.
So the arc equals the diameter?
The arc, no. The arc is still half the, yeah. The diameter tells you that it's half the circle. All right, Theorem 1010 says a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So quadrilateral being 4 sides, inscribed meaning the vertices of that quadrilateral are on the circle. If this is true, and it doesn't have to be a rectangle or a rhombus or a square, it's just a quadrilateral. If that's true, then the opposite angles are supplementary, but the opposite angles add up to 180 degrees. So in this diagram, angle 1 and angle 3 would add up to 180, and angle 2 and angle 4 would add up to 180. All right, so useful fact number 1, okay, says that an angle inscribed in a semicircle is a right angle. So this is just the application of what we talked about, okay? So if you've got the angle inscribed where the 2 sides are on the outside of the diameter, it's 90 degrees. So and if it's 90 degrees, it's a right angle. That's all the link is here. Useful fact 2, the measure of an angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. So the inscribed angle had the vertex on the circle, both of the sides were chords. In this case, you're dealing with a chord and a tangent. But the actual measure is the same. So if I've got a chord and a tangent, the angle it forms, which is here, is 1/2 the length of this arc. So they're both found the same way. They're formed 2 different ways, but they're both found the same way. So if I said this arc was 130 degrees, what would be the measure of angle 1?
70.
Close. 65, okay? If I told you that so then that means that this would be 230, right? Because it would have to add up to 360. What would be the measure of angle 2? 115. Okay, does that make sense?
Yeah.
And we said this was 65, and we said this is 115. What's true about 65 plus 115? 180. Does that make sense? They form a line, right? Okay. All right, so you find the values of x and y in the circle. So sometimes the hardest part is figuring out what it's looking for, okay? So if you zoom in on this one a little bit, okay, that O at the point in the middle is your center. Angle y is this angle here, which goes from this chord to this chord. And angle x is this angle here. And it's telling you that the angle here, or sorry, not angle x, yeah, that's angle, but the arc is the x. The angle is 20 degrees, which tells you what about x? It's 40, it's double the angle. So then if y intercepts this arc, first find the measure of the arc. What's the measure of the arc? It's 110 plus 40. So this is 150. So then what's the measure of this angle? 75. Alexis.
So the y is pointing to the whole angle?
So the y is pointing to the whole angle. Yeah, that's why it gives you that blue arc. So y is
Wait,
75.
so would this tiny little angle right here be 20?
Yes.
And this would be 50 or 45?
55.
55?
Mm-hmm. No, y is the whole blue angle. Mm-hmm. This little segment here, this one, would actually be 20 because it's half the arc that's 40, right? And then this one would be 55 because 75 minus 20 is 55, which makes sense because this arc is 110 and it should be half that arc. So all of it still relates. All the rules about sides and angles, about lines and angles still apply inside that circle. Mm-hmm.
You said that would be 20.
All right, now the y, again, pay attention to that arc. So the y is this whole angle here. The x is this angle here. And all I know so far is that this is 20. Where does that take you, Nick?
With that big angle, why would it equal 40? Or would it equal
The green y, you mean? No, not 40.
10?
Mm-mm. The arc would be 40. Is that what you're talking about?
Yeah.
This arc would be 40. Right? Because it's double the 20. Then what?
Then x would be 20.
Yep, 20, which you didn't even have to get the arc, right? Because x and the other angle would be congruent because they intercept the same arc. But either way, you do it. So what else is in that diagram that I haven't used?
The rest of the circle.
Mm-hmm.
It's 80.
Mm. Emily, why? So this is angle y, right? The end of the angle, the sides intersect the end points of what's this called? The diameter, right? Which makes it 90 degrees. Or that cuts the circle in half. This whole arc is 180 degrees. And then that's an intercepted angle on the arc, which is half, which is 90 degrees.
Is there any
So
other
either
way
way.
of finding it besides like knowing that definition?
No. No, you'd have to be able to find at least the other arc or the sides. Yeah. Okay. So in this diagram, I know that this is 60 degrees, and this arc is 140 degrees. Where can you go from there? Evan.
You know that the one angle is 70 degrees,
This would be 70 degrees. Okay.
and then the triangle has to add it. So the triangle has to add it to 180.
Okay, so 70 plus 60 is 130. Subtract that from 180. 50. So this angle is 50 degrees. Where's that get you?
Y equals 100?
The arc equals 100, right? This arc would equal 100 because it's double the 50, which means y is what? 50. Okay, it's half that arc.
And then can't you add 50 and 70 and the x is going to equal 180 minus x?
Sure can. So 50 plus 70 is 120, and then all three of these angles have to add up to 180. So 180 minus 120 is 60 degrees, which is x. Or you could have gone the other way, right? I could have used 60 degrees, double it to get this arc, which would be 120, and then the x is half the arc, which would be 60 degrees. Lourdes?
Wait, so those aren't congruency marks?
No. They'll usually be red if they're congruency marks. I know that that's a little confusing.
How do you know that it has to equal 180?
Because it's a line. It still forms a line. So the rules about a line still apply. Yep. Okay. D. So see the red congruency marks. So those are congruent. So what's true about x? It's 40. It's half of 80, which is 40. Okay. What's true about y?
Equals
How do I know?
Because 80 is like the opposite, then you subtract 180 minus 80.
So this is 100. Yep. And then congruent chords form congruent arcs. So this is 100, which means this one has to be 80. This would have to be 50. Yep. Half the 100. Alex.
Could you also say like that angle is 90 and then
So you can tell that this one's 90,
and then that one is like 42 at the bottom, and then you could do like the
but you don't know it's 40 at the bottom. Does that make sense? You could get there technically,
Yeah.
because that would be hypotenuse leg, which would make them congruent. So yeah, you could get there eventually.
Where'd you get 100?
So that line is, this line is your diameter, which means that this would be half the circle, and you had the 80.
Oh, when you-
Yep. Any other questions on those? So there's a lot of different ways to get to these, okay? Just when you thought you couldn't have any more fun. It says, given circle O is equal to circle P, arc AC is equal to arc AB. Prove that triangle ABD is congruent to triangle ACE.
Wait, is that a proof?
It's sneaky because it says the word prove, right?
Just by chance.
Who said there's going to be proof on your test? We haven't even made it yet. Don't worry. There's no stress yet. Okay, so where do we start?
Nowhere.
That's a bad plan. Okay, circle O equals circle. And arc AC equals arc AB. Given. So why would they tell you that they're congruent? What does that tell you?
That everything's equal.
Not everything. The radii are congruent. Okay, by definition, does that make sense? The radii are congruent, yes? Okay, so that means that this is congruent to this. This is congruent to this. So if I wanted to state that, I would say DO equals OA equals AP equals PE. And that's the definition of congruent circles. Now what?
What about pointing?
It's a point of tangency, but it doesn't get you any part of the measurement. Okay, it is the point that's shared though.
Or then the angle BDA is congruent to CE
How?
because if the arcs are congruent, they're opposite in half. So,
Wait, which angles? CEA? Yeah?
yeah,
So you're saying this one's congruent to this one?
yeah.
Yeah. So angle CEA is congruent to angle BDA. And actually, first you might have to link those two arcs. Yeah, I would do that first. So because arc AB equals arc AC, so let me move that step down because you'd have to state that one first. So in here, you'd have to state that angle CEA is equal to 1/2 arc AC, and angle BDA is equal to 1/2 arc AB. And that's the definition of intercepted arc. Definition of intercepted. No, actually, it's not a definition, it's a theorem. So intercepted, inscribed, holy moly, inscribed equal 1/2 the arc. And then you would have to say that angle CEA equals 1/2 arc AB, and that's substitution. So we said that AB is equal to AC, and then we switch the value out. So now we're saying that it's equal to AB. That's substitution, and then we can get to 3. with another substitution. Alejandro.
Isn't there a quicker way to get there?
There probably is. We're going to follow this one because we're still going. We're still okay.
What, okay, could you also say that, like, since DA equals AB, that both the opposite angles would do the same thing?
And that's, you're talking about B and C, angle B and C.
Yeah.
So you can say that without even having the two be congruent, because what's true about angle B and angle C?
That they're opposite from the diameter.
Which makes them what?
90 degrees.
So are they equal to each other? Yeah. So you could have gone that route. And we still need one more piece of information, so that might even be the one that we use, right? Because all I've said is so far, I have one pair of sides and one pair of angles congruent. So I can also do that last one. So I can say, wait, so my numbers are off. This is 3, this is 4, this is 5, this is 6. So I can say that angle B equals 90 degrees and angle C equals 90 degrees. And that's if an angle inscribed in the diameter, then it equals 90 degrees. And then I can say angle B equals angle C. And that's substitution. And now I've got side, angle, angle, right? Or angle, side, side.
Yeah, there's no such thing as angle side.
I have angle, angle, side.
Yeah.
Did I say angle, side, side?
Yeah.
I have angle, angle, side, sorry. I have angle, angle, side. So there is one, like you could have also said that because the arcs are congruent, let me zoom in on it. Because the arcs are congruent, we said that B, A, C, these two arcs are congruent. What's true about the chords then? The two chords would be congruent, right? So I could say that BA equals CA, and then I can use that in combination with the other stuff. With the right angle, that would be angle, side the other way. So you could do it the other way. So there's more than one way to do these, just like usual, there's more than one way to do a proof, okay?
What happens if canvas doesn't work?